trying to work out this area here, which is shaded. I don't know why I've reshaded it. So, a couple of things here that you're looking at it. You know that there are 3 circles. They're all exactly the same thing. So each radius is 4 centimeters. So actually, when you look at it like that, we've got radii of 4 centimeters each. We're actually going to have to use a few different skills here to work out this answer. First thing we're going to need to know is the area of a circle, which is pi r squared. You're also going to have to know the area of a triangle, which is half AB sine C. There's a non-calculator paper, but we're going to have to figure this out anyway. And we're also going to have to work out the area of a sector. So area of a sector, which is the angle over 360 times by pi r squared. We can draw a radius here and we can draw a radius here. And actually what you're left with is, well, what I've drawn is an equilateral triangle. And what that means is I have an angle of 60 for an equilateral triangle. But also, if I use this lovely blue colour here, you notice I've got a sector that's been drawn here. And actually, if we think about it in that way, this little segment and this little segment are the same. But what's also nice is that actually this is the same thing repeated here, 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 and here. So we can only work it out. We only need to work it out for one of them, and then we can just go back and... So let's look at the triangle. In this case, like I said beforehand, it's going to be half times by AB, which will be 4 times by 4 times by sine 60, because it's an equal. But essentially, you know that, well, essentially I know that it's going to end up becoming root 3 over 2. So therefore, the area of the triangle is going to be, multiplying all of this together, that becomes 4, that becomes that, so then that becomes 4 root 3 for the area of the triangle. Now let's work out the area of the sector. The area of the sector is going to be 60 over 360 times by pi times by 4 squared. That's the same as 1/6 of 16 times by pi. So then that's going to be equal to 8 over 3 pi. So working out the area of this little segment, I've coloured in red for whatever reason, area of the sector minus the area of the triangle. So then what we've actually left with here is that becomes 8 over 3 pi minus 4 root 3 for the segment, which is in red. So knowing all of that, I can actually work out the area of this entire weird semicircle looking thing here. That's going to be the area of a sector plus one area of a segment. So we have the area of this sector taken care of, and the area of this little segment. So the area of the sector plus the area of the segment. So in total, putting that together, oh, silly me, I forgot the pi. Putting that together, I'm going to end up with 16 over 3 pi minus 4 root 3. And that's one of them done. So now, let's use that to work out the area of the shaded bit. Now, for that to begin with, we're going to have to work out the area of the actual circle B. And then in total then, the shaded area, or the two shaded regions, are going to be 16 pi minus 4 lots of whatever I'm writing here. And then we'll expand it out. So we're going to end up with 16 pi minus, and be careful with the minus sign here, I've done this enough times, 64 over 3 pi plus 16 root 3. Then we just need to put those together, which ends up becoming 16, or minus 16, over 3 pi plus 16 root 3. And that, ladies and gentlemen, is your answer. Hopefully you found this helpful. Please give it a like if you did. And yeah, and if you found it really helpful, just give it a comment. I don't care what you write, just say something. Yay! Say something nice.